Good evening, everybody. My name is Oikarinen.
And I'm Tuisku Sarrala.
And we're going to talk about privacy threat modeling, how you can discover privacy problems from the data lifecycle of your applications. But first of all, who are we? Who are you, Tuisku?
I'm a privacy consultant at Nixu, and I love extreme sports and getting into dangerous situations, but I also love techie stuff and, of course, privacy problems.
And I'm a security consultant in Nixu. I really like threat modeling. I've been doing this and that in cybersecurity, but this is something that allows us to find weaknesses early. I've been a computer geek since kid. This is me and my first computer. I'm like 8 in that. And that's a so-called portable computer because it weighs nearly 10 kilos, something really heavy.
So, we are here to hear about privacy threat modeling, but what if I first told you that there is actually no agreed definition about privacy? You know, we need to get a better idea of that before we start. It's not the GDPR. That's about data protection. And various laws, they try to ensure privacy, but you know, the legal definitions and people's own definitions, they do differ. And it still differs massively across societies and cultures and across time. You know, what is privacy? So I thought it would be a nice idea to look at, you know, how we've seen it through time. Going back to the hunter-gatherers times, people lived in huts, and you know, there were no secrets really. You knew, you know, everything really. People started living in houses that created some kind of a boundary. You would have your own room. That would mean this is my private space. And then you'd have postal service. People started thinking, wait, somebody else shouldn't read my letters. So the idea of private correspondence came up. In 1890, that's when, say, the first proper definition came up. Warren and Brandeis wrote a law article in Harvard Law Review. And they defined privacy as the right to be let alone. And that's, Mikko Hyppönen talked about, you know, how technological changes have, you know, brought all these challenges. And this was kind of the same thing. So around that time, people could start taking pictures. They could start recording voice and so on. And it was realized that, you know, they could make this public. And then there was this concern that, you know, you shouldn't really publish stuff about private people. Going Second World War, after that, the idea of human rights came up. And privacy was recognized as a human right then. So people's private, family, home life, or correspondence should not be interfered with. Okay, this was an interesting one. Alan West in 1967, very influential piece. He wrote about privacy and freedom, this piece. And there he defined privacy as claim of individuals, groups, or institutions. I think that's quite interesting. Institutions could have privacy too. To determine themselves to what extent, and to whom information should be released to, how information should be communicated to others. So it is something about self-determined privacy. Then we'd have Cold War, and states would be the enemy to privacy, bit different kind of idea. We would have the first data protection law, 1990, the EU Data Protection Directive. Going forward, the GDPR era, we would have a social media, and maybe companies would start becoming the enemy, to our privacy. And what's happening now, what's happening in the future? If we look at the My Data movement, for example, it's quite interesting because it goes back to the Alan Westin-style idea of freedom, where persons should themselves determine, what privacy means, and they should be in control what is released and to who, and they should know what information goes out. So before you start threat modeling, you need to think about what is privacy to you, what kind of privacy you want to implement in your system or target of the modeling. So you probably need to do something about GDPR, how well the company sort of protects the data. You might want to also do some kind of ideological, self-determined style, user choice and control. Or you may want to ensure secrecy, anonymity, hiding of data. Leave no trace. And because you probably have to do GDPR, let's be clear about that. We often talk about GDPR as synonymous to privacy, but actually the GDPR doesn't really mention the word privacy many times at all, and it doesn't actually define it, because, as I said earlier, GDPR is about data protection. It does recognize privacy as a fundamental right, but then that is balanced against private interests, business interests, and so on. It's about good management of people's information and making sure that the personal data use doesn't harm people, and also making sure that you set your security to the level of the data sensitivity and the uses that you are going to use the data for.
Then the other part of the puzzle, what is threat modeling? Well, the general idea is to think that what can go wrong and what can we do about it. It's not being pessimistic to the maximum, it's just systematically thinking that what are the possible negative scenarios and what's the impact. Threat modeling techniques like STRIDE focus on architecture and data flows. In addition, you should consider things like system features, maintenance, development, and also privacy, topic of the day. And when we put privacy and threat modeling together, what do we get? Well, first of all, the general idea, thinking what can go wrong in terms of privacy, is really good starting point. We can think about system features. Maybe they are designed incorrectly. Maybe there's a flaw in the implementation. What about architecture or the components that we use? Maybe there are vulnerabilities, weaknesses again. Then there might be loopholes in the data lifecycle, in the processes how we handle data. And as Tuisku said, it's good to understand what is the privacy that you're aiming for. Are you building an application, a messaging app for whistleblowers? Are you going for total anonymity? Are you handling health data, or are you building an app for hair salon appointments? Different kind of privacy needed. There are existing threat modeling approaches. There's LINDDUN. All the letters mean a specific privacy threat. It's really useful to understand these concepts. When is linkability a problem? What does detectability mean? And so on. But LINDDUN, the pure approach, focuses on data flows and the anonymity of data flows. Well, it's useful if you're going for the total anonymity minimization of everything. But the problem is that it doesn't really give the idea of the data lifecycle. It just gives you a snapshot of the system at one point in time. Then there's TRIM. It's created by this cybersecurity company that you might have heard of, F-Secure. Well, TRIM has also very useful concepts to understand for threat modeling, like minimization, transferring of data. And when you use it, you need to understand the business use cases for privacy. But what these models seem to lack is taking a look at the data lifecycle. Data always has a lifecycle, especially personal data.
So, a special quality about privacy threats is there is always a victim. And the victim is not the company, okay? Or at least it's not the useful focus to have the company as the victim. So the user is your primary asset, and you need to protect them because they may be the victim of the privacy threat. And this will help you to spot relevant threats and understand also how critical they are, because you always relate it to the person. And if you think about health and safety laws, so it's quite similar to that. So they require companies to protect people from getting injured or getting from dying, even. And similarly, in privacy, you try to protect the person from getting somehow harmed by the way you use their personal data. So to the company, the consequence is always sanctions or reputational risk. But let's leave that on the background. Another useful thing to think about is these threats are often accidental or unintentional. So people may not think or understand, how they're handling the data, and things such like poor management of people's information, or use cases that harm people, or security is not just set to the same level or to the level it should be for the sensitivity of data.
To help you take into account all these baddies, harm doers, and people who make mistakes, we have collected these users as something called cyber bogies. Cyber bogies is a term coined up by my colleague, Tero Vanska. He's an excellent threat modeler. These characters are based on caricatures and stereotypes. Like in movies, you might have the superhero and then villain. And in our office, we might have someone who's really helpful and may be likely to fall for social engineering scams. And we're going to tag these characters along our presentation to remind you of the threats they bring. And before we go to the data lifecycle, we're going to present this example system that we're going to use for highlighting what kind of threats you can discover and how to make threat modeling privacy practical. And this is a dog fitness tracker application. There's a device that you put on your dog. It's a collar. It has a GPS on it. It collects the location of the dog all the time. A SIM card, it sends the data to the cloud, and the owner can check the location of the dog and activity on a mobile app. Real-time activity reports, workout reports, nutrition tips. There's a dating feature. Whoa, how nice. And you can find your pet all the time.
So Anne was talking about the cyber bogies, so I'm going to talk about different kind of characters. Again, useful to think about them as characters, and they're the users, and as I said earlier, they are primary asset. So it's a really good idea to get to know your users, think about who they might be, because different users attract different kind of risks. You can see, these sort of users, they may be military personnel, couples, kids, so on. It does make a big difference. It helps you to find the relevant threats. And let's break it up. So we're going to start threat modeling this device. So this is the target of the modeling, the dog fitness tracker. Your primary asset is the user. At the end, you are trying to protect them, okay? The target of the attack is their personal data. so how they might be harmed through attacks to their personal data. And the attacks may come via the device, any software around it, any business processes around it, because we're talking about data lifecycle, so we need to think about those processes as well that are outside of this physical thing, the business and the people there. So you need to understand all these aspects to do your threat modeling. And to help you to get on the right track, these are the sort of things that you need to watch out for, how people might be harmed through an attack to their personal data. Privacy is there, of course. And a few more concrete examples, what to watch out for. So with these thoughts, let's go into the actual threat modeling cycle.
And this is the life cycle we've been talking about. 5 phases: collecting data, storing data, handling data, then anonymizing or pseudonymizing data for sharing purposes, and then finally removing data. And logically, we're going to start with collecting data. But you register for a new application. Well, you will fill in your name or email address typically, maybe your birthday, gender, location, all kinds of things. And what's not visible in the form, well, your IP address might get collected, your operating system version and name, browser settings, browser language, all kinds of things. And when you use the service, it gets collected again. With Dog Fitness Tracker, let's take a look about the GPS data collection. This is what the design team thought it should work. Let's keep the GPS data collection always on so we get accurate activity statistics, no problems in finding your dog if it gets lost, all that.
That sounds useful. So if I was the user, this would track my dog all the time. I would be able to see where they are at any time. And
yeah.
I could put it in my boyfriend's car and I could see where they go.
That's useful.
I guess if we think about the evil cyber bogies, then a stalker could do the same, I guess.
OK, well, what if we put a button on the collar so you can disable and enable the location tracking? Would that be better?
That is a good idea. And actually, that goes with the privacy by design and privacy by default. So you would make sure that all the features are turned off so that privacy doesn't get breached and users can make the choice to, be tracked or not to be tracked.
OK, let's do that. So,
sorry.
Sorry.
Just to remind you about the users.
Yeah.
It's a good idea to, at every step, just think about, is this an opportunity or could this harm the users?
Anyway, there are loads of threats or cyber bogies when you collect data. First of all, the data may be wrong. You faked something, or you make a typo when the email address is incorrect. Some extra data may be collected, like images may contain the location tags. Or you transmit it insecurely, something is showing in the URL. But actually, it's the legal side. I mean, you can collect some of the data for business purposes or vital interest, and sometimes you need to ask for consent. So how do you know?
You should go back to thinking, what sort of privacy you're actually wanting to implement. If you're wanting to implement the sort of user choice and control, then of course you would ask the users every time and make sure that they can change their mind anytime. But if you're doing something like GDPR style, you could rely on contracts or, maybe legitimate business interests or something else to just collect the data. So it depends.
Right. And the next phase is storing data. All the places where you keep it, databases, files, logs, temporary caches. Now you need to take a look at the architecture. And with the dog fitness tracker, well, different kind of needs for storage. And here, access to data and storage goes hand in hand. First of all, someone from the UA might want to keep the production data and store it in the testing system as well to make better tests. OK, let's see. Maybe the testing environment is less secure. You add new features, maybe they are containing bugs. And then all these extra people may be rummaging around the system. External consultants like us doing pen testing. Is it really necessary that they see all these names and, in this case, location of real people? I don't think so. I would go for generating the data from scratch or using pseudonymization. Then new features. Well, I was actually working in a project once where the project manager wanted to keep all the data forever, just in case they think of a new feature that they can use it for. And I think he was the only person in Europe who had not heard about GDPR. Unfortunately, you cannot just collect everything and store it forever unless you really have a purpose for it. And then logs. Debugging, useful. Actually also proving that you have done security and privacy right. But if you log too much, you end up having another personal data storage. Who needs to see that information again? If you're debugging a problem in your code, maybe you don't need to see that location, info, email addresses of real people. And analytics, Power BI, ClickSense, do it in your Excel. If you store something to another computer, it becomes a new storage. Is it secure enough? And for statistical purposes, I would go for anonymized data, probably enough. Well, again, many things to think about threats in storing data. First of all, is the data confidential? Where do you actually keep it? And all the places you keep it, all the temporary ones, logs. Then think about who can access the data and how they access it. Maybe there's something in the configuration, it's a bit insecurely configured. You're using weak passwords. Maybe somebody can bypass the authentication. And when you think about databases, well, might be tempting to use email addresses as unique identifiers because, well, hey, they're unique per person. But hey, you can also identify the person from the email address really easily.
OK, so you have collected all this data. What next? So the next step is handling it. That's a core lifecycle step. And here we want to focus what you do with all the data and, are you handling it properly and what could happen to users through that. Again, accidental and unintentional threats are very significant here. So a large number of data leaks can happen through mishandling of people's information. Like last year, a database of the personal records of almost everyone in Ecuador was leaked because of sloppy misconfiguration of Elasticsearch. And that was 16.5 million people, and that's about 3 times the people in Finland. That's pretty significant. And 2 years ago in the US, health records went missing because somebody left unencrypted laptop in a car. Again, these things can happen so easily, just simple errors. But then bad things can happen as well when businesses try to keep their products current and exciting. and they come up with new uses with the data they already have. And of course, they forget that it's not their data, it's the user's data.
Yeah, so we have now collected all this data from different dogs. We could have a new feature to match the lifestyles of these dogs, like somebody who likes city walks, somebody who likes to play in the park, and the owner can have someone to talk to while taking the dog to the walk.
So we get all this data, feed it to the AI, and then come up with some great stuff, some matches maybe, how dogs, similar lifestyles. Why not?
Yeah, I think we have all the data we can try it out.
Sure. Okay, so the AI department went and took all this data and came up with this nice dog matching feature for the app. So what we can see here is it looks like a pretty nice walk. The dog went around the Ternelahti area and seems to like nice long walks and probably pretty fit dog. Or am I actually looking at the owner here, because every dog has an owner, and whose data is this at the end? I wonder what else I can tell from this data.
So this is how the design team did it. Well, looks pretty nice, doesn't it?
Yeah, it looks great. So we have this new feature on the app where Bella has found a match with the little Bernie, and they both like long walks, they both like city walks, they both like evening walks. That sounds like a really nice match.
Yeah. Although it says that they both go to this AA meeting really often, is that really something we need to show and know about all these details and routes?
That's pretty private, I would say.
Yeah.
So all sorts of threats can emerge from the handling of data. You really need to think about, do you actually need that amount of detail? Can you achieve the same result with a bit less granularity or something more general? And also, as we just saw, new use cases for data, they can be problematic. And you need to think about the users. Did they give the data to you for that reason, or what was the original reason for it? And think about the cyber bogies. Maybe a malicious admin could turn the tracking on remotely and see where the dog is going. And I think we need to remember that all kind of people own dogs. The president also has a dog, and these people who are these malicious cyber bogies who've got interest in these kind of people, they would have the resources to do that. And how about if you built a website that showed some statistical data, maybe about the dogs, maybe by filtering by area, by dog breed. If you had a really special kind of breed, there was only one in the area, a stalker or burglar could actually find out when you're in and when you're out, and yeah, that would be pretty bad. So from those kind of thoughts, we go into anonymization and pseudonymization. And these techniques you would use if you want to use the data without revealing who the data is about. So like in this example, when you want to put some data on a website and maybe use it for some statistical purposes. However, you can easily create a privacy risk by using these techniques if you do not know what you're doing, if you don't do them properly. And if we talk about anonymization, that's essentially a personal data removal technique, because after that, you can't reverse it, you can't tell anymore who the data is about. And Pseudonymization, that is a security technique, which means that you have a key and you have the data, and you can still tell, if you need to, who the person is. So here is the case. Let's say the company, they've got all this data, lots of very, very good data, they want to sell it. That's a pretty common use case. And they think, they're going to remove all the identifying data so that, it's anonymous and it's safe to sell. So they are going to go with removing the device ID, name, address, email address, phone number. OK, but is that enough?
Well, let's see. News from January 2018. The fitness app Strava was supposed to be anonymized, but, well, there was a flaw in it. And by calculating the midpoints from the starting point and the ending point of the workout, you could practically deduce where somebody lives. Again, in July 2018, another fitness app, Polar, they had this feature where you can show your routes. They were supposed to be even private, and you can select if they're private or public. But then you could actually browse to somebody's private workout routes if you just tampered the URL. So it's not easy, apparently.
So again, we have some threats there. You might have noticed that the anonymization, pseudonymization is not really a lifecycle step as such, but because of the threats, because how you use these techniques, it's actually worth looking at it as a separate step. It's not probably enough to just remove the identifying attributes. Not all may understand this, so that may raise a threat. Or people don't simply recognize what's identifying information. It might be that the number of attributes is so large in the data set that you can tell by just looking at them together, who the person is. Or maybe the data set is so small that you can, by deduction, tell who it is about. An employee, social engineering victim, they could be tricked into sending some data sets out. Maybe if it's been pseudonymized, it might be that both of them look totally safe, do not appear to have any identifying information, but together, actually, they reveal people's identities. So it's not easy. And we want to think about, we don't know what is enough, how can you get there? And in some cases, actually, it may not be possible. It's nearly impossible to anonymize data completely. But there are some techniques. For example, Apple uses this differential privacy. I would say go and search for it and read a bit more. It uses putting random noise in aggregate data and tries to anonymize it that way. Or you could try anonymizing the data at the user end, so that when it leaves the user, it's already anonymized. But then the company may not necessarily be able to use it for some calculations or something, so there is a trade-off. But something to really keep in mind and look what's the right sort of level when you think about the users and the threats to the users. So if it's military, if it's some private individuals and so on, it does make a difference.
And the final phase is removing data, or at least the identifiable parts of data. And let's see, well, expectations that when does the data actually get removed may vary a lot. Somebody might think that now that I have removed this app from my phone, it's completely gone, also from the cloud, forever. But actually, why not? If your users haven't been using the service for like a year, maybe you can send them an email that, are you going to use this service again? And if nobody replies, just delete it.
But it would be really sad if I got a notification when my dog had already passed away. And
That's true.
maybe I want to keep the data for sentimental reasons, How about then?
Anyway, life happens. Maybe you broke up. You don't want to see your ex-spouse's walks and routes anymore. Or maybe you want to sell the device. It's not really useful for a hamster, maybe, after all. But you want to ensure that there's nothing in the device that will identify you.
And who knows, you might have an internal threat, a cyber bogey that's an evil data scientist and just wants to hoard the information and just keep it forever.
There are, again, many threats in removing data, many people actually affecting it and the security of it. Do you remove data automatically or manually? If you do it manually, maybe you forget a step sometimes. You don't remove all the data, and not from every place. Or what if you restore backups? You may need to remove the data again, and from all the places. It might be all sort of secondary storages. So, yeah, difficult. And many things to remember.
And so, if you think about data removal, you may assume that you just mean like removing all the data at once. But actually, users may have different wishes and different requirements. So how can you make sure that your system supports the idea of maybe removing only some data attributes and so on?
Yeah.
And there might be legal reasons for keep some data for much longer than some other data. And what does actually trigger that if it's set in 20 years ahead?
Yeah.
That's
what
not
if,
always thought about.
Yeah, and what if the dog data is actually data of multiple people, all the people who have worked with it? Can you remove one person from the data set? Is it technically possible?
That's a good point, because a piece of data can actually be, one piece of data can be data of two people,
Yeah.
so you can't actually then separate it. So
Yeah, you would remove the other person as well along. Yeah.
And it's not always up to the company to decide, what the data retention period should be, because a person could ask you to actually retain it past the retention time. And what do you do then? Can you make sure that you keep it? OK, we've gone through the data lifecycle, and we've got loads of threats now. What do we do next?
If your system is not totally ready, you might want to iterate a bit this threat modeling process. First, start with the overall idea of the system. That is it going to fly? Are people going to use it? Does it feel OK? Is it legal to collect and handle the data that way? And think about the first features as well. Next time you do threat modeling, you can think about the first features, a bit about the storage and handling, and then go over to pseudonymization if you need it, removal of data. And what's important to keep in mind that when you discover all these threats, don't just forget them. Try to think, what do you need to do? How can you mitigate the threat? Do you need to change the feature somehow? Do you need to add a security control? And put all these mitigations to your backlog. And when you're doing this brainstorming, you might need some help. Think about the LINDDUN model, all this linkability and detectability. And think of how these threats would apply to your system. And then you can use the cyber bogey cards. We're actually going to release them pretty soon, so check our Nixu Tiger team Twitter account. We will tell you when they're ready. And the cards that relate to TRIM, these elevation of privacy cards, actually they have really useful examples, concrete examples that you can reflect on how this would work on your system again. And next thing to do is risk analysis.
OK, so let's imagine we have some 2 dozen, 3 dozen, hundreds of threats gathered in that ball. How do we actually know that they are relevant? What do we do with them, whether they are something to worry about or not? we understand that people can be harmed, but we are running a business, so how to relate to that to the business as well. We need to remember that threat modeling and risk assessment are two distinct processes. In you uncover threats, and risks you assess, so you put them through that risk assessment mincer, and out comes your risk treatment decisions. And OK, so you need to remember to evaluate them at the right level. So let's think you've discovered some threats, you know your system vulnerabilities, you've understood the context and the nature of the data you have, you know your users, that was important, and the consequences, you've kind of uncovered them together with the threats. Then if you can do something about them, yeah, go ahead and fix them. Yeah, definitely. But of course, you can only do stuff within your remit and within your resources, you know, the money and time you have. And you might be left with stuff that you cannot fix. And these is best that you feed them in the proper risk assessment process of the company, because they may be compliance threats. And compliance threats, they sit at the company level. They are boss-level risks, because they can mean bad stuff to the company, you know, sanctions, reputation risk, compliance risk that a developer cannot really carry. And what the company does, it then has to think about, you know, what its resources are and make a proper, you know, formal analysis of it. And here it's really important to remember that it's not really for the company to decide that, you know, what their risk appetite is with these kind of things, as they might be able to do with financial risk. They can't think, you know, let's make a risky financial decision. You know, that's fine. But creating a system, a product that's risky for people, that's just not right. And so the law is there to protect people from getting injured, getting harmed, and it says, you know, you need to be able to reduce the risk so that it doesn't produce any significant risk to people. So, and if you don't do this process, then you're breaking the law, unfortunately.
Privacy threat modeling actually makes your product better. It's nicer for the end users to use. You have less weaknesses. And as a bonus, it can be GDPR compliant as well. It's vital to think about that what kind of privacy are you aiming for? Child anonymity, my data, my control, compliance type of privacy, or maybe all of them. And it's important to take the user viewpoint. Users are important in privacy. How are they going to use the system? How could they misuse the system, maybe? And remember that your intention for privacy can actually go wrong. If you don't think about the threats in the design, or if you don't test your implementation, you might actually end up harming privacy. Remember those news about anonymization flaws? Or maybe your data request feature actually allows to take a look at other people's data. And take the full data lifecycle into account, from the moment of collecting data to the moment of deleting it. Thank you for listening.